So what is that point? 2, where are you getting that from? You're taking this red one here, and that happens to be the x-intercept of this red curve, which means if you just set that equal to 0, you get x is 2, right? You could even look at it as the intersection between the green and the red. Isn't that what that is? So if I set that equal to that, then it's the same equation, right? 0 equals x minus 2. Solve that, you get 2. So am I okay to just put 2 here without any work? While we're at it, because we're going to need it, let's try and figure out this one. How am I going to get that one? I need to set the square root of x equal to what? X minus 2. I need to know where this red one, which is x minus 2, hits the blue one, root x. And now that equation, back in college algebra, we called a radical equation. And do you remember the process to solve a radical equation? You isolate the radical, which is already done. You square both sides. So let's square both sides. Square this side, you get x. Square this side. You actually have to like square the whole side, right? So FOIL it out. You should get 4x plus 4. So that's what the right side would be. What type of equation is this? Quadratic. By the way, what I'm doing here is I'm finding the intersection, right? And I'll move everything to one side. That means I'm just going to subtract an x from both sides. And that factors again, doesn't it? It's my lucky day. Minus 4 minus 1. And then you get 2 solutions, right? X is 4 and 1. That seems wrong, doesn't it? Well, guess what? Do you remember this back when you were doing radical equations in college algebra? That when you square both sides, you introduce the possibility of extraneous solutions. You have to see which one works. So if we go back to the original equation, root x times x minus 2, let's check 4 in here. 4, square root of 4, 2. 4 minus 2, 2, 2, 2, check. Plug in 1. Root 1, 1. 1 minus 2, negative 1. So this one is out. It's an extraneous solution. So 4 is the answer. So we know this is 4. All right. Top function minus bottom function. Let's try and do it. This region right here, what's the integral for that region going to be? 0, 2. Then it's going to be the top function, take away the bottom function, right? What's the top function? Root x. Bottom function? 0. So isn't this just root x? Root x minus 0 is just root x. And then I just put dx. That should give you the area of that first little piece. Then, once we do that, we want to add to that the area of this region, which will be the integral from 2 to 4. This time we have to account for something though, right? Because our rectangle in here, the top is root x, right? Minus, but the bottom is x minus 2. So how should I write this? X minus 2? In parentheses, good. You have to, if you're going to subtract two terms, you've got to subtract each one, so make sure you put that x minus 2 in parentheses. And I'll go even better. I'm going to put all of that in parentheses like that. Questions? Whatever that is the area, right? All right, let's take it all the way. Okay, this equals, let's do the antiderivative. Antiderivative of root x is 2/3 x to the 3 halves, right? It was a good break, wasn't it? That is correct. So that's the antiderivative, evaluation bar, 0, 2. I'll take care of that in a minute. Let's do this one right here. And just to save myself one line, this right here becomes what? Root x minus x plus 2. Right? That's what this is when I distribute. Okay, so let's integrate each of these. Root x, I'm putting plus here. Antiderivative root x, we just did that, didn't we? 2/3 x to the 3/2. Antiderivative of negative x, negative 1/2 x squared. And finally, antiderivative of 2, 2x. Evaluating 2 to 4.
Why do you put it after?
Put what after?
Like, the line 2x.
This thing? Well, that's what we did with all definite integrals. Remember? So like if that was the only problem I gave you right there, the first thing you do is find the antiderivative, which is this. Then you'd put that bar behind it and then the two numbers, and then you plug in and subtract. Is that what you're asking me?
Yeah, I guess because I always write it like twice. Like I write it first and then I write it behind it with the numbers actually in it again.
Well, I'm going to do that, yeah. That's my next line. I'm going to actually plug the numbers in. I'm not done. So now what I need to do for this one, right, is say I'm going to plug in 2, right, and subtract what I get when I plug in 0. So what happens when you plug in 2? Ooh, that's yucky. It's 2/3 times 2 to the 3/2, isn't it? That's what it is, whatever that number is. And I'm not going to break my calculator out or anything. I'm just going to leave it for right now. Then I plug in 0 for x. Well, that one's easy. That kills off everything, doesn't it? Plus, now I plug in 4 and then I plug in 2 and subtract. So plug in 4, plug in 2, right, subtract. So what about 4 in here? What does this mean? 4 to the 3/2. We've done this a few times, I think. Isn't that the same as square root of 4 cubed? What's square root of 4? 2 and then cubed? 8. So this is, when we plug in 4 right here, we get 8 right there, don't we? Times 2/3 is 16/3. Now, why didn't I do that over here? Because the square root of 2 is not a nice number, so that's why I stopped. All right, I said, plus I see something else is about to happen. So let's see, 4 goes in here now. 4 squared, 16 times 1/2, so minus 8. And then plus 4 goes in there, 8. Oh, those are going to go away. That's kind of nice. Now plug in your 2. Do you see what I was saying? Something nice? Does that look familiar? 2 into here. That right there is this out here. And this one's going to be subtracted once I do that, so they're going to go away. Just so happens to do that. Okay, 2 in here. 2 squared, 4, half of that, negative 2. And finally, plus 4. Are we all on the same page? All right, let's drop some parentheses, and let's kill some things off right now. How about the 8s? You happy with that going away? How about if I take this and get rid of it now with this? You believe that? 0's gone. So really the only thing left is 16/3. And then this right here, when I put these two together, that's 2, right? But then I'm subtracting it. So how about minus 2? And now common denominator, 10/3. .33333. That's the area. What do y'all think? So you've been waiting all week, you've been just itching to come back for this, haven't you? 4 weeks? No, I think, well, I hope not. Is it 4 weeks?
It's a longer.
I think it's a little
Yeah,
more.
until
I think it's like 6
second-
weeks.
second week of May, first week of May.
All right, I need a drink of water or something. I'm going to go get something. While I'm getting that, I want you to look at this again. I just want you to consider maybe that we could have done this a different way. It won't take me long, but while I'm doing this, just think about, could you have done this a different way? What are your thoughts? Any thoughts? Horizontal.
Yeah, just kidding.
Horizontal. So think about if you did your rectangles horizontal instead, what the advantages or disadvantages might be. Yeah, if we do horizontal, you're never going to have to switch because the function that's creating the right boundary never changes, right? No matter where you are. And the function creating the left boundary never changes. So that, to me, is good because we don't have to break it into two integrals. The disadvantage, I guess, if there is one, is that these were functions of functions of x to begin with, right? We would need to make them functions of y. So how do we do that? Solve for x instead of solving for y. So take a look at each of these. Y is equal to root x. Can you solve that for x? Square both sides. So you get y squared is x. In other words, x is y squared. You could say that x is some function of y, which is y squared. See how that works? Instead of saying y is a function of x, you're saying x is a function of y. So I could label this blue one as, what, f of y is y squared? Yeah, and the other one's a little easier. If I'm going to take y equals x minus 2 and solve it for x, I just add 2 to both sides. I get x is equal to y plus 2. And now this x is some function, I'm not going to use f again, g of y, which is y plus 2. So I could label this red one as g of y equals y plus 2. Y'all understand that? Now we still have another issue to deal with. What's the other issue we have to deal with? The limits of integration. And remember, because we're going and we've switched it over to a horizontal rectangle, our limits of integration are going to be our limits on y instead of on x. So what's the lower limit for this region? 0. That's here. And then this top one, 2. So where are you getting that? Where do we get the 2 from? It was 4 and it went up to 2. But let's act like we didn't do that, though. How would we do that? Yeah, you just take, we want to know where the red one and the blue one hit each other, right? So I want to know when this one is equal to this one. Right? Set them equal. It's a quadratic. It'll factor. I'm not going to go through the work, but you would get the solutions. And this would come out to be 2. Understand that step? All right. So let's set up this integral. The integral would be from where to where? 0 to 2. Now be careful on this because I labeled this one f and this one g. It's not always f take away g, right? It's the one on the, well, when it's the other way, it's top minus bottom. In this case, it's always right minus left. So it's going to actually be the y plus 2, right? Take away the y squared. dy. And then plug in, right? Integrate, plug in. Antiderivative is 1/2 y squared plus 2y minus 1/3 y cubed, evaluated 0 to 2. I already like this better because I'm only going to have to do one evaluation, and plugging 0 in is going to be easy, right? 0 is going to kill everything off. So just plug 2 in, and we're done. So plug in 2. 2. 4 minus 8/3. That's 6 minus 8/3. What should we get? 10/3. This is 18/3 minus 8/3, which is 10/3. So which one do you think was easier? Think this one was a little easier? Doesn't matter to me, okay? I mean, you get to the right answer, that's the most important thing. I think this is better, this way, looking at it as horizontal instead of vertical. All right. Y'all seem to be okay with this? Is my feeling right here or no? Oh, that's the same problem. Sketch the region bounded by y equals sine x, y equals x equals pi over 2, x equals pi. Find the area of that region. Y equals sine x. It keeps going, right? But I'm just going to draw one period of that. Let's, for the sake of not making this more complicated than it has to be right now, let's skip y equals x just for a moment. X is pi over 2. What is that? It's a vertical line. And it has an x value of pi over 2, which should correspond with the peak of the sine function, shouldn't it? So I'm going to have a vertical line here at pi over 2. That's another curve. And then another one, x equals pi, that should correspond to this point, right? That's halfway through the period of sine. So got this, that's x is pi. This one was x is pi over 2. And trying to find a region enclosed by all of these. Now let's bring in the y equals x. And I held off on it intentionally because of the following thing that's about to happen. Y equals x should be in here like this, right? But I don't know how good my drawing is. So look, if I do this, then isn't my region going to be this little piece right here? But if it's actually sloped up more like this, then won't my region be like this thing right in here? Do y'all see that little piece right there? So the question is my line going to be on that intersection point right there? Is it going to be above it, or is it going to be on this side? That's what we have to figure out. And there's one easy way to do it. If the function is y equals x, right? Y equals x, then what's the value of this function at pi over 2? Pi over 2, right? So when I draw this, right? When I draw a diagonal line, at 1 it's 1, right? At 2 it's 2, and at pi over 2 it's pi over 2, right? So what is pi over 2, approximately? Pi divided by 2 on a calculator is like 1 point something, right? Bigger than 1. And what do we know about this sine curve? That's 1, right? So I know that when I go to pi over 2 and draw up, I should be above it somewhere, like this. And of course we know it goes through the origin. So my graph is going to be something like this. That's my y equals x.